In this video, I'm going to show you how to calculate the VIRP chart for the parallel circuit. In this circuit, two light bulbs, 10 ohms and 30 ohms, are connected in parallel to a 4.50 volt battery. Determine the voltage, current, resistance, and power, or VIRP, for all components of the circuit. On the left, you see in green the circuit diagram, two resistors connected in parallel. Then you see the VIRP chart. And then in the red box, you see all the formulas that apply to a parallel circuit arrangement. If you recall the previous video, I showed you how to determine the VIRP chart for a series circuit. I use the same type of resistors, and what I ask that you do is you compare the results of this VIRP chart, the parallel one, to the VIRP chart of the series connection, and you will recognize some of the differences between the series connection and the parallel connection. So I'll return to that idea later on. So what I'm going to do first is I'm going to put into the VIRP chart what I know already, what I'm given, and I'm told that the resistances of the two resistors are 10 ohms and 30 ohms, and I know that the total voltage is given as 4.50 volts. So now what I need to do is calculate the rest of the values. So if I look at the VIRP chart, I see that the place to start probably would be to determine the total resistance. That's really my only choice. So let's take the resistance formula for parallel circuits. 1 over RT is 1 over R1 plus 1 over R2. 1 over RT is equal to 1 over 10 plus 1 over 30. Now, I could do this manually. I can find the common denominator, but I have a calculator, so I think that's much easier. So I'm just going to convert the two fractions to decimals. So 1 over RT is equal to 0.100, that is 1/10, plus 1 over 30th, 1 divided by 30 is 0.033 repeating. But I think 0.033 is enough. I'm recording the information with a level of precision to the closest 10/100,000th decimal place. So if I add those two decimals together, I get 1 over RT is equal to 0.133. So that means RT is equal to the reciprocal, which is 7.52 ohms. Okay, so this is 7.52 ohms. Now, I want to make a point here, the 7.52 ohms. Notice that if I was to take the 10 and the 30 ohm resistors and connect them in series, the total resistance would be 10 plus 30, or 40. When you connect resistors in series, the resistance goes up. However, if you connect the same resistors in parallel, you'll notice that the resistance goes down. 7.5 is a resistance lower than the 10 ohm resistor. So keep that in mind. The next thing I'm going to do is calculate what IT is. So I'll use Ohm's law. VT is equal to IT times RT. VT is 4.50 volts. IT I want to calculate. RT is 7.52 ohms. So IT is 4.5 divided by 7.52, and that works out to 0.598, almost 0.6 amps. So add that to the chart. So 0.598 amps. Okay, so I want to point out another thing, and I'll write this one down. So note, IT is greater in a parallel connection compared to a series configuration using the same resistors. And this is because the current has multiple paths to take in a parallel connection. So let's just put a little box around this. Okay. So again, I want you to compare series versus parallel, so you understand not only the mechanics, how to connect the series in a chain, and in a parallel, they're going to be next to one another, as you see in the schematic on the screen. But I also want you to understand what happens to the current as a result of the different types of connections. Okay, so moving along, I can state that the voltage is all the same. Vt is equal to V1 is equal to V2 is equal to 4.50 volts. That's what we see in a parallel circuit. So this is 4.50 volts, and V1 is also 4.50 volts. Okay, all the voltages are the same. So now, since I have the voltages and I have the resistors, I can now calculate the currents using Ohm's law. So V1 is equal to I1R1, V1 4.50 volts, I1 times 10. So I1 is equal to 4.5 divided by 10, or 0.450 amps. And I do the same thing with V2. That's I2 times R2, 4.50. I2 times 30. So I2 is equal to 0.150 amps. So let's add those two numbers to the chart. So 0.450 amps and 0.150 amps. And you notice if you take these two numbers and add them together, that works out to 0.6, which is very close to the total that we got earlier. Now finally, the power calculation. Power is equal to IV. So power 1 is equal to I1V1. So power 1 is equal to 0.450 times 4.50. P1 is equal to 2.03 watts. And I'm starting to run out of room here. Let's do P2, I2, V2. P2 is equal to current of 0.150 times 4.50. So P2 is equal to 0.675 watts. I'm not sure why I put that in parentheses, but it still works. Okay, so Let's do, here, I'll do this in red over here, just so it's pronounced. The total power would be IT times VT. So PT is equal to 0.598 times VT, 7.52. So PT is 4.50 watts. So we can transfer those numbers, 2.03 0.675 and 4.50 watts. Okay. Now, the last thing I want to make a note of, I'll make it here. Just realize I made a mistake. Okay. So what else is new? So let's go back to, we can erase this very easily. Maybe I can't. Okay, I'm going to give up. Do it this way. I put the wrong number in here. So the VT is actually, this should be 4.50, and 0.598 times 4.50. Just do that on a calculator. 0.598 times 4.5 is 2.69, and that makes a lot more sense. 2.69 watts. Okay. So the last thing I want to make a note of, I'll put down here in the bottom right-hand corner. In parallel, bulbs glow brighter, and consequently, batteries drain faster because there's more energy used up to create that brighter light.